Saeed, welcome to the show. Thanks for coming on.
Good morning. I'm in Chicago, so good morning, good afternoon for you. Yes, thank you for having me.
Hello and welcome to the Take Charge podcast. Can heat really be a battery's friend? Well, today I'm joined by Saeed Al-Hallaj, who is the Chief Battery Scientist at Beam Global. Beam Global acquired a company called AllCell back in 2022, which the company Saeed founded all the way back in 2008. So, of course, Saeed joined in that acquisition. I caught his presentation back at the battery show in Michigan last year, and since then I was very interested to bring him onto the show and for him to take charge. So he starts off by talking us through the eVTOL downtime issue, and then how their technology allows for extreme fast charge whilst taking advantage of heat, whilst also showcasing their thermal management and safety capabilities. Saeed also talks us through Beam's EV charging pods, which is an amazing innovation. It's fascinating. I think it will make a huge contribution to the adoption of EVs for many years to come. And finally, he talks us through what the future has in store for their technology, which includes artificial intelligence for fleet optimization. So, without further ado, we hope you enjoy the episode. Let's take charge. So let's start with you first of all, your background, your academic background, maybe AllCell that you founded back in 08-09, and how you then eventually became a member of the Beam Global team.
Well, thank you. So again, thank you for the opportunity and to come and chat with you a little bit about the work that I've been doing for a while. So my journey with the lithium battery world started at the Illinois Institute of Technology in Chicago here a while ago. There was a project for Soldier Future program funded by the Army Research Office where we started looking at lithium batteries. Soon after, Sony came up for personal electronics. And over the years, my PhD actually was in chemical engineering, and it was on thermal management and safety of lithium-ion batteries. And out of that came some IP that, at the time, I was thinking about my career, and I decided, you know what, I'm just going to stick to R&D at the university. But I actually started the AllCell out of the university to actually commercialize the technology. And we started in the tech park, but like you mentioned, in 2008, we took the company out of the Illinois Tech Park, and the journey started.
Very good. So am I right in thinking that the acquisition happened in 2022? So Beam Global acquired AllCell?
Yes. Yeah. Almost 2 years, a little bit over 2 years ago. Yes.
Nice. And your role now, you're the chief scientist. Talk us through kind of what you do at Beam Global.
So I have I love my title. It's very fancy. Chief battery scientist, which is mainly my focus is actually on battery research, R&D. I work with a couple of universities, national labs, and we continue to push the envelope on technology innovation, especially lithium-ion batteries. There's a lot of there's a lot of research happening, but what I focus on is actually how can we enable the technology to do stuff that can allow it to operate safely and extend its life in what I call extreme environment. And that's what we focus on, is how can we offer our customers who are making fun stuff a battery that has the lightest weight, the smallest, and actually the best performance for what I call under extreme condition, cold or hot weather.
Great. We're of course going to be going into some detail on your solution, your technology. Let's go right to the very beginning. You mentioned coming out of the university and thinking about your career. What kind of sparked that interest in thermal runaway and safety in your eyes?
Yeah, so it was actually my the way I got into this. I was in a group in the Illinois Tech that works on the batteries and fuel cells, and I knew I mean chemical engineering. We are good at understanding thermal management, material, and so on. But I didn't know batteries. So when the professor asked at the time who was my partner, it's like, we need someone to work at thermal management. Do you know batteries? Are you kidding? My middle name is batteries. I didn't know much about batteries. So I had to quickly take class in electrochemistry. What I realized when I started doing some testing, we did something called ARC testing, which is accelerated calorimetry. I realized quickly that lithium batteries, or even those small batteries, are, chemical reactions in some sense when they go to thermal runaway. So what happened is, if you heat up these batteries to a certain temperature, which is called trigger temperature, they start reacting, generating oxygen, what it calls self-sustained reaction, and they actually, if you leave it, they blow up. And that for me was very similar to the way we design reactors, chemical engineering. And I felt like, oh, I know this stuff, so that's what triggered my interest, is from my background that we deal with this stuff all the time. And that's something that I notice in the lithium-ion batteries, that some people in, non-chemical engineer side don't have the right background for that sometimes.
Well, I mean, you and I were talking before the recording today about the crazy weather on your side, the crazy weather on our side as well, and the need to electrify the future as soon as possible. But of course, when that happens, battery safety has to be of utmost importance, and battery fires and things just cannot happen. At the moment, it's still lithium ion and many EVs, and obviously we're looking at eVTOL as a potential future solution as well. We'll get into the solutions there and the kind of thermal runway and kind of how that stops things. But before we do that, talk us through kind of generally what Beam Global do. Because I remember a previous conversation we had about the EV charging pods. So slightly different, but I was fascinated by that solution.
Yeah. So early on, this actually, when we started doing this work a while ago, 10 years ago, people were not thinking about the infrastructure and not thinking about what happens if. But my background, actually, I worked in renewable energy, a combination and energy storage, which go hand in hand. And we realized a while ago that the minute you start putting more solar in the grid, you're going to start disrupting the grid in a way that, you need to find ways to regulate the grid. So more renewable, which is nice. At the time, we realized quickly this problem. That's actually some of the early storage solution that we worked on. So when the EV project started, nobody was thinking like, oh, it's going to come to a point where we're going to have problem charging these cars. And that's why actually the distinct factor we understood early on. And I used to work with Beam, by the way, was my customer when I was running my battery company. We realized that, the future is going to happen faster than people thought. And there's going to be, the EV infrastructure is going to be a problem. And when we did some work, realized some of the things about when you hook up to the grid, there's so much work that you have to do before you even install the equipment, permitting, digging, wiring, all that stuff. That was actually very time consuming, very expensive. So Beam Global, what realized is that what if I can have a self-contained EV infrastructure that you can deploy literally in hours anywhere in the world. So what it is self-contained, we call it run by sunshine. So you power PV with tracking, storage, and an EV charger. And this is something that you can deploy anywhere. You can put it in a parking lot without actually taking space. And that's something that people, I've sometimes overlooked, that especially in congested areas, every inch of square real estate is important. You don't want to do anything. So you literally come in, you drop it, open it, and you leave. And that is something that we feel that we have pioneered, and we have done enough to actually gain the trust and had, ton of units that are deployed globally right now. And we're just getting started, by the way. We think that this is, as you can hear about EV infrastructure problems, we feel like we're just getting started. We're going to continue to push and then hopefully offer our customers unique and effective solutions for that EV infrastructure problem.
Nice. Yeah, I was going to ask on the status of that product. So you say it's commercially available right now. And in terms of the actual charging capability, does it allow for extreme fast charge as well, or fast charge in today's world?
Yeah. So what we have, for Beam Global, our product, we had it for the last 10 years, more than 10 years, actually deployed all over the place. But what you will see that our product is deployed in areas like, extreme hot condition, Arizona, Phoenix, and areas and so on, but also in the Northeast when you have weather that is, a little bit cold. I think you live in Spain, you probably don't. I'm sure you've heard about our weather. Minus 20 in my place is common.
I don't know what the cold is these days. I'm not sure.
Yeah, and unfortunately, the extreme weather, because of all what's happening with climate change, is getting actually very, very extreme. So what you'll see, the pattern is the cold day is going to get colder, longer. The warm day is going to get warmer. So you're going to have more of those. So when you deploy these solutions, you have to take that into account. And you have to take into account that you cannot, people want to just get in charge and move, and they don't want to deal with all the other problems. So we take that into account in all of our engineering, product selection, and even in the installation when we do that.
Great. As you say, in terms of tapping into the grid, it's time consuming, it's expensive, it takes a long time. So yeah, I think this solution is fascinating. to kind of bridge that gap. We're going to have more EVs on the road, so we need to be able to charge them somehow to drive consumer adoption. So yeah, very interesting. Moving on to your kind of other solutions that kind of focus on battery safety and thermal runaway. I caught your presentation at the battery show in Novi last year. Really fascinating takeaways. So let's kind of talk about the problem first of all. It was about eVTOL downtime. So kind of summarize the problem for us first of all.
Yeah. So if you look at the use patterns for a lot of electric mobility, what we notice actually. There are two types. There's the type that you think, electric cars, the Teslas, all that. And that is actually not very challenging. I hate to say that. The battery is oversized for the application. And most of these cars are actually, most of the time, they're sitting. They're not moving around. And the cost of ownership is actually taking into account that. When you talk about fleets or commercial fleets, whether it's an eVTOL that, taxis, thinking of when O'Hare here, you do not want to drive from O'Hare to Chicago downtown in rush hour. It takes a long time. It's painful. So if you can, actually United Airline announced that hopefully next couple of years, people like you, Jamie, when you come to O'Hare, you don't have to wait like us in traffic. So you can hop in one of those electric planes or, eVTOLs, and it takes you downtown in 10 minutes. Now, the reason this is critical is not just, think of it as not just because of congestion and air pollution and all that. But there's a lot of that happened that actually, even I saw some application for emergencies, for organ donors time of an issue. So think of it, there's a huge application for that actually helped that right now, some of it replacing ground, but some of them replacing helicopters. So for those, if you think about the commercial, these vehicles make money when they're in the air, when they're transferring goods or people. When they're down, they're not making money. And that affects the return on investment tremendously. The same way today, we think of it, I'll just take a simple example that we deal with some customers who have material handling equipment in warehouses all over Chicago. They are 24/7. So every time you sit down to charge the vehicle, that takes time that, people think that takes out from return investment. So in the case of eVTOL, we noticed that we looked at the profiles, and some of those which are we call short trips, they actually spend more time on the ground charging. It takes 3 to 4 hours to charge than the trip. Trip itself literally probably takes less than an hour, sometimes half hour. But after 2-3 trips, you have to sit down and charge. So that takes out the vehicle. So what we thought, okay, what if we can find a way to reduce that downtime of those eVTOLs, or to that matter, fleets in general, by accelerating fast charge? What can we do to accelerate fast charge with these? Now, the challenge that you see in the eVTOL, the battery has to be the highest energy density, smallest, and all that, which means those batteries in general, the chemistry is not, does not take fast charge very well. And that's where we took the challenge.
Yeah, as you say, in terms of that eVTOL downtime and extreme fast charge capability, if it's being used as a air ambulance, then
yes,
somebody in trouble isn't going to wait for the battery to be recharged. It's super important for it to be charged in 5 minutes, 10 minutes, or however long is needed. But yeah, super important, as well as, of course, getting people to and from the airport. So obviously, with the increased temperature becomes, fast charge becomes increased temperature and risk of thermal runaway. The PCC solution you discussed was fascinating. So yeah, expand a little bit more on that for me.
Yeah, so our solution, which is actually, I have a prop for you, which is
nice.
It's a composite. It's a phase change composite. Think of it as a matrix that you can actually. This is one of those commercial cells that you can drop the cell in it, literally, right? And it becomes like containment, but also it has a graphite and wax, which is we call phase change material. So what it does is when a cell is heating up, it moves the heat very quickly to make it uniform, and then start melting at a specific temperature that we select to maintain the battery safety and what we call performance or cycle life. So by doing so, you have what we call a passive control. You don't need moving parts. You don't need liquid or air. And by utilizing that property, then we can allow those batteries to operate at those high, in what we call high discharge condition, even highest charge, without sacrificing life or safety.
Brilliant. So in this case, is heat a good thing with this solution?
So yeah, so this is where we actually we I want to say we are genius, but we got lucky. So in some of those work we were doing, typically what most people do, and that's why you need the downtime. When you discharge the battery very fast, in the case of flying in eVTOL or fast moving vehicle or whatever battery, then the battery heats up. Typically when it heats up, especially when you reach above 40 degrees Celsius, 50, 60, the common practice is to cool it down to 25 degrees Celsius before you start charging it. So in some of our application, we're looking at that. We know with our customers, our customers do crazy things like, electric surfing, scooters, motorcycles, race, hyperloop, stuff like that. So we were like, okay, what if we can charge it right away? We know that you cannot charge it above 50 Celsius, maybe even 45, because we know that there's electrochemical damage. But I was like, what? Well, let's start at 40. So we noticed actually, if you charge these, what's called NMC, nickel, manganese, cobalt, if you charge it at 40, you actually find out that it's actually less impedance, which means generate less heat. And it's actually, you can zap it probably 50, 60% of its charge in less than 15 minutes, which means the manufacturer tells you take it down 25 and you cannot go more than 1 hour. By doing this, we discovered that actually you can zap it 50, 60% in less than 15 minutes. So we started that, and actually we took it. There was a national competition funded by Shell called Game Changer and managed by the Department of Energy, National Energy Lab. So we came out like, look, we think that something is happening here, that we have data to show that actually it stops the battery impedance growth and nothing bad happened, actually, if you control the window and the temperature. And we won actually an award. We won award from the Shell competition, and we worked with National Energy Lab, and we found actually it makes sense. At these high temperatures, around 40, 45, NMC impedance is lower because the kinetics of moving ions is actually better. But we found actually lithium plating, which is the biggest culprit for plating on the anode and causing thermal runaway, actually is inhibited at high temperature because it needs higher activation energy. Now, there's a window that you can do that of both temperature, which is around 40, 45, and SOC, which is about 50, 60, you have to control the voltage. And if you do that properly with smart BMS and our material for phase change material, we actually showed that you can do that, and you can enable fast charging and double the number of trips you can do per day. So that was how the whole thing started, which is initially it was like an observation counterintuitive what we saw, but then now there's ample evidence in the literature actually explains that happened, and we published some of that work too.
Brilliant. We had a previous guest on the show, Brian Marin from Soterian, and that was all about e-bike battery safety. So obviously similarities, but this was more around actually how the pack is put together, rather than the actual kind of cell and the chemistry and things like that. And he was talking about, okay, it was lithium ion, they could solve most of the problem. There's still going to be problems there because it's lithium ion, but very, very simple ways in which they could improve battery safety. From this perspective, in terms of fast charging and, the amount of times thermal runaway happens upon charging, do you have kind of any facts and figures to highlight the current problem?
Yeah, so actually it's very sad, exactly what you mentioned. E-bike incidents and some of those personal electronics are very sad, and in some areas cause some fires and people's death. So we take it very serious. But I've been working in this field for over 20 years, and there's billions of battery cells that are manufactured. And there's a rule of thumb that we realized many years ago, and which is in quality control. This is called Six Sigma. You've heard of it. But in lithium-ion batteries, it's actually better than that. But there's statistics that show, there's some small percentage, very small percentage, like few cells in millions of cells every year that could fail catastrophically. So what does that mean? When you build as an engineer or battery manufacturer, when you put cells of thousands or tens of thousands of cells together in a pack, you have to take that into account. What can I do if one of those cells fails catastrophically? And that's where the engineering, manufacturing, quality control comes in, and technology like ours, who can actually, what we do, we assume something bad is going to happen, and we designed our material to actually contain that catastrophic failure of a cell, so it does not spread to the rest. In fact, and you prevent what's called domino effect or catastrophic thermal runaway. But what I want to point out is that, a lot of cases showed that actually there's bad quality cells, there are bad quality packs, battery management system, or even chargers that do not actually communicate with the battery to understand when you go overcharge or fast charge and cause problems. Because lithium batteries are you cannot fast charge them beyond certain voltage. You cannot fast charge them, even charge them at cold temperature, below zero, for example, because the electrolyte frozen and you end up blowing up the battery. So what I would say is that, I'm optimistic that we'll find solution, but you can build a fantastic, battery if you use high quality component manufacturing processes and go through the proper certification processes to make sure that everything goes well. But you can build safe, good performance pack from, average quality cells, or at the same time, you can build a terrible pack that could cause catastrophic from good components if you don't put it together. So I would say that we need to take more care of, going from A to Z, quality components, good processes, checks and balances, but also make sure that the whole, the battery could be good, but if the charge does not communicate with the battery, bad things could happen. So you got to have protection, communication, good quality, but at the end, you have to assume that one cell or a couple of cells are going to fail. What do you do about that? How can you contain it? And that's where I see a lot of regulatory requirements, certifications that are coming, in the next few years to actually address those kind of challenges. I hope that I answered your question, by the way.
No, it's highlighting the issues, and for sure, there are many. We've obviously talked about eVTOL as an application. In terms of your technology, is it applicable to all, compatible with all applications? Is it compatible with all different types of cells and chemistries? Or
yeah, so what we did, which we actually just recently had some patent issued, and we have been doing this for the last 5 years. What we do is we look at the eVTOL. You need the highest energy cells, and for example, those small cylindrical cells that are 21700, 4680 that Tesla's coming with, you're going to get around 300 watt-hour per kilogram, 260 to 300. So this is high energy, which means that electrode you can fast discharge them up to 2 SEER safely, which what we do, but fast charging is a challenge. Now, when you do that, you need actually the battery management system, the electronics part to communicate, and the battery management, which is the brain, to actually communicate and understand how the cell electrochemistry reacting. So, for example, if you pulse it and you see that's plating, you can detect that by looking at the voltage with time. So if you have smart battery management system, combine it with material, and then you have these, what I would call the control of the vehicle. You can do amazing things with all kind of application, whether eVTOL, forklifts or material handling, or I would say, for example, scooters. Like you said, if people want to, in urban areas, you want to keep them running. So you can do that. You can apply it. There are limitations to everything. And the challenge always for us to become what problem I'm solving, what value that I give my customers. I hate when I work with my students, my engineers, like, don't come up with a technology that looks for a problem. Always listen to the consumer, listen to the user, and see how you can enable it. So what we do, we understand the cell electrochemistry very well, and we study it, we model it, and then we start to do things to enable its use in a safe way and in a way that does not tax the user for aging of the cells or some safety issue.
Well, I think you touched upon it, the intelligent battery thermal management system that you have. Expand on that a little bit more, so I know that kind of works in conjunction.
Sure. So I'll walk you through some of the things that recently actually we're working on, and it happened. It made the headlines a few months ago in Chicago in the U.S. when there was massive cold weather. Most Tesla vehicles could not be charged. Not just Tesla, everybody could not fast charge their batteries because the batteries challenged. So what supposedly intelligent battery management does is understand the very minute details of the electrochemistry of the cells. It can probe the cell and the pack as a whole and start giving instruction to the charge or discharge. So it can tell you, for example, if let's say it's under cold weather, it will tell you, you cannot charge the battery. Can you heat it? And there are many ways to heat the battery. There's active systems. We have our own, which is using PCM around current. So then as you monitor the cell, you can instruct the electronics, say, you know what, you can charge it at this level. And again, so you can modulate instead of, specific. You can, in the future, you'll start modulating. I can start modulating the charge and accelerate the charging based on temperature health of the battery. So that's one way of doing it. Now, the same thing in the discharge. If you have an intelligent battery system and, hot weather, you're running home, thermal condition, it will tell you if you hit the point where you actually start getting to the point where the battery is going to be damaged, it will start telling you, like, slow down. And if it reach a point where something even failed, it will detect it and will what's called throttling. We'll take you home safely and take you to the mechanic, and then they can go in and take it out. So that type of detection, monitoring, and adjustment, which is called dynamic charge, for example, in cold weather, is something that you'll see happening in a lot of application that, people don't want to just in binary option. Yes, you can drive the vehicle or not. Yes, you can charge it or not. And what's exciting for us, we're working with universities. There's some machine learning, AI, and all that stuff. Imagine if I can do that for a fleet of thousands of vehicles, and I can decide, how to deploy them, how to plan them, and learn as we move along, and feed that into this intelligent battery management system, and combine all those together. It's going to unlock a lot of value because, if you look at the cost of a vehicle, battery is the biggest cost. If I can enable the battery to do more things for my customer and my user, by just unlocking these things and enable them to smart materials, smart electronics, and smart use or machine learning, I think there's a lot of room here for innovation, a lot of room for more enabling of lithium batteries in a lot of areas.
Amazing. Yeah, I think in terms of the solutions, it's got clear benefits from a consumer adoption standpoint and convenience. As you said there, it's kind of off or on. It's like, okay, it's on, but it needs fixing, take it somewhere, and that can be done safely. And then obviously the safety element. And, we've been talking about eVTOL as an application and where it's needed the most because of the thermal runaway risks, the high temperature. Given the application of eVTOL, as you said, it could be an air ambulance. And if one of these things explodes in the sky, or whether it's been charged at the time, and the kind of headlines that will create isn't very good. Of course, it's going to make headlines because a patient could have been saved, a life was lost, or whatever. And then also, in terms of the way the world works, I guess eVTOL application, somebody getting a transport to the airport, it's going to be pretty high profile people, people who have the cash to be able to do so. I think you mentioned I'd be doing that unless it was for a tour, a sample. I'm not too sure yet. But it's going to be high profile people, which again is going to make headlines. So I think that's why it's super important for this to be done safely and responsibly.
I totally agree. I tell people, they ask me, like, what is the difference between eVTOL and a car? I said, we take automotive industry for granted, but imagine when your car overheats, radiator blows up. You see that in movies, right? You sit down the road, you get out of the car, and you complain, but you call someone, they come and pick you up or tow your car. And in eVTOL, you don't have that luxury. So whatever we do when we work with people who work on those, kind of application, they take safety like number one, number two, number three. And then in that case, and we worked actually also my early work with some of the works with the Army Research Office around, safety and people who use it. You cannot compromise on that. You cannot say, oh, I'm 99%. I mean, you cannot do that. We work with NASA, work all this. So when we do this, like I mentioned to you, we say, okay, what can I do to make sure that all these scenarios, something bad happens, that I can help mitigate it, give the pilot time to actually just address the problem, but everything within their means to take them safe, back safe. And that's what we focus on. In our solution, what we say, okay, yes, we want to maximize performance, but if something bad happened, first of all, contain it. That's what the material does. Then the electronics start what's called isolation. So isolate, if there's a module failing, a cell in the module, isolate that, work the other ones, and immediately give the pilot or the user even in some cases, going to be all autonomous. Give the controller the ability to go home safe and operate in what's called, you can downgrade what I call throttle down, but you cannot sacrifice the return trip. And that's what we do. And we say, okay, we're going to do all that within the limitation of the electrochemistry, with the electronics, is all that. So and then that's what I always tell my engineers and my students. I was like, if you can do things right, and I hate that, but it's fact, 1 + 1 is not 2 anymore. It becomes more than 2. And that's what we do by, if we do engineering and we do optimization and we do smart designs and utilization of this technology without compromising safety, I think we're going to offer people a lot of help and people get excited. And we need that. We need to move to electrify everything, because we cannot afford to say, you know what, we're going to have a setback and go back to, before. We just need to figure out the problems, be honest about it, see what we can address through material solution manufacturing, but see what we can engineer around a little bit to buy time till the next generation of battery chemistry comes out.
For sure. And yes, in terms of driving adoption, whether it's a high profile person or someone who's not necessarily in the media, it's going to be a big story, but
100%.
But it's going to have more of an impact. It's just the way the world works with the media. And if that's happening, it's going to put fear in people not to use this sort of technology, and therefore we're just going to keep relying on fossil fuels. Really important work that you're doing. Just before we kind of finish off, you touched upon it before, in terms of the future for your technology, and you touched upon AI for fleet optimization. So kind of delve a little bit deeper into that for me.
Yeah, so it's amazing that when we think about this, there is application actually that are, even today with all that, you need to find ways to make sure that when people transfer to the new technology, it's something that they say, okay, what am I sacrificing? And the last thing they're going to say, just you're doing it for the good of the environment. Like, that's fine, that's great. But if you want it to be sustainable, especially businesses, you have to show them either they make money or save them money or giving them some value. What is your added value? And in this case, I want to stress that for a lot of those electric vehicle application, e-mobility application, whether it's personal passenger vehicles or delivery trucks, which you see a lot today with e-commerce, the battery cost and the battery itself is probably the biggest single component in the history of automotive. Right now, even the engine that you make combustion is probably a few $100 for a Lexus or Mercedes. A battery is thousands, in some cases tens of thousands of batteries. So the question, how can I maximize use of battery, and how can I use those vehicles in a way that actually, whether planning for charging, whether planning for discharge, whether planning for different environment, can I be able to collect that data and be able to learn from it, and actually for future dispatchment be able to utilize it better? I'll give you one example, that things that I read a few years ago that blew my mind. Apparently UPS studied in New York that they don't allow truck drivers to turn left in an intersection. I don't want to exaggerate, but it turned out they just turn left adds tremendous, delay time. So just by avoiding that, based on data, they were able to save a lot. So imagine the value here. If we know what the battery is used, if we can predict when the battery can last, enhance it through, ways of temperature maintenance, charge and discharge, deployment, which areas that I can charge. Because every time you charge and discharge the battery, you actually use. For example, a lot of people make the mistake of keeping their phone battery or electronics fully charged. That is actually not good for the life of the battery. There's ways to keep it. So if I can manage to do a lot of that stuff by good understanding of electrochemistry, the app, and the value of each one of them, whether fast charge, discharge, I'm going to make sure that the next generation implementation of electrification is going to be like, I'm crazy not to do it. I'm saving time. I'm saving the environment. I'm getting all these cool technology with electrification. It would be crazy not to do it. And that's where we want to be. We don't want the batteries to be any hurdle, whether economic use or safety. We want it to actually make it easier and actually entice people to do it.
I think, AI has a huge future to place in every future conversation on the production of batteries, but then also the usage of them, as you say, to increase longevity and cycle life. Exciting. Good luck with that work. Saeed, I've loved speaking to you about all of this. It's sort of something you've done a lot of work on over your whole life. Excited to see what the future holds for you and Beam. We've just started a new a kind of new thing for the show, which is a previous guest asks a future guest a question to answer. So yeah, obviously this is a complete surprise. You haven't seen the question before. And this isn't the previous guest as well, so you can't say it was, well, it's been released today, Bloom Energy, so it's not Bloom Energy. So the question previous guest has asked is, if you didn't have to earn any money, what would you do with your life?
Oh my God, I'm doing it. Look where I am. I'm teaching in the university, doing research. I'm having the time of my life, and with my position with Beam, I'm blessed that they allow me to do research and stuff, and then come up, like, talk to you about stuff that, we're going to hopefully get implemented in the next few years. Honestly, I'm living it. The only thing that I would love to do is just try your job for a few days, see how it works to be on the other side, ask questions. I have not tried that. Maybe I'll give it a shot.
You seem like a very happy person. So that's...
Thank you.
I should probably anticipate that answer. Well, I'll say congratulations on all your success with AllCell and now Beam Global. And yeah, good luck with all the work that you're doing.
Thank you very much for the opportunity. And again, thank you for what you're doing. I really enjoy listening to all the guests. I think they bring a lot, and you ask very, very good questions, and hopefully we'll continue to have these conversations.
Thank you. You have to say that, but thank you, Saeed. I appreciate it.
Thank you. Have a good one.
Stay safe.
Take care.
Thank you.